Hi, this video is about showing you how to break up some multiplications to make them easier to do. And I've had a request to do things in high definition, so you could switch to high definition now. Here's 4, our friend, because it's an easy number to work with. Here is 5 lots of 4, which we could think of as a multiplication of 5 times 4. Now just suppose that we didn't really know how to do 5 times 4. What could we do to help ourselves? We could split it maybe into a couple of things that we do know. How about 4 times 4 and an extra 1 times 4? If we know what 4 times 4 is and we know what 1 times 4 is, then when we add the answers together, we will get 5 times 4. Okay? Now that is quite clever, because if we can do 4 times 4 and add 1 times 4, I wonder what else we could do. Maybe we could split the 5 times 4 into 3 times 4 and a 2 times 4. I'm sure that would work, because then when you put those together, you would get 5 times 4 again. Well, that's good. And what about if we had it the other way around and we did 2 times 4 and a 3 times 4, or 1 times 4 and a 4 times 4? I think that's still going to work. There you go, the power of maths. What we're doing there, by splitting it like this, is taking advantage of a particular property that multiplication has, called the distributive property, which allows you to separate or partition or split one of the numbers, or even both of the numbers that you're multiplying, into numbers, into smaller sections, then multiply them each separately, and then add the results. So I've split 5 into 1 and 4, and then multiplied the 1 by 4 and the 4 by 4, and then when you get those answers you can add them together, and that will give you the same answer as 5 times 4. And I've done the same down here as well. Okay, so that's an example with those. What about, instead of 5 times 4, if I had 6 times 4? There's 6 times 4. How could I split that and use the distributive property of multiplication to make it easier if I didn't know how to do 6 times 4? I could break that into good old 5 times 4, which we've seen so much of. There it is, there's 5 times 4. And what do you need to go with 5 times 4? So that in total you end up doing 6 lots of 4. That's right, you just need 1 extra 4. So you could split it like that, a 5 times 4 and a 1 times 4. Or, what else could you do? You could do a 4 times 4 and a 2 times 4. And how would that look? That would look like that. And once you've done that, because bear in mind that's all still 6 times 4, you could have a go at doing 3 times 4 and another 3 times 4. There we go. And when you put those two answers together, you'll get 6 times 4 again. That's quite useful, and it can be used with harder calculations as well, not just these straightforward ones that I've just shown you. Let's try it with 3s. Okay, there's 1 lot of 3. Here's 5 lots of 3. 5 times 3, okay? I'll keep those all together. That's 5 times 3. Now I'll get another lot of 5 times 3. There we go. So altogether we've now got how much? That's right, 10 times 3. And then another pile of 5 times 3. So altogether we've now got 15 times 3. And then another pile of 3s. So altogether we've now got, what have we got? We've got 20 lots of 3. 20 times 3. Okay. 20 times 3. Here's an extra 1 lot of 3. So in total we've now got, we've now got 21 times 3. Another 3, and we would have 22 times 3. Another 3, and we would have 23 times 3. So you can see how I'm building this up. Right, well, how does it become useful? It becomes useful when we want to do 23 times 3 and we want to try and do this in our heads. We can separate this out into 20 times 3 and 3 times 3 and work out the answer. We could do it if it gets a little bit bigger and it becomes 24 times 3, or if it becomes 25 times 3. Separate out the 25 into a 20 and a 5 and we'll calculate them separately. So 20 times 3 is 60, 5 times 3 is 15, add 60 and 15 together and you get 75. That was quite an easy way to do it. If we didn't know how to do 25 times 3 in our heads, we can split it into 20 times 3 and 5 times 3, do those calculations in our heads and then add them together to get the answer. And if it works for numbers like that, I wonder if it works in other examples, such as 2.5 times 3. Maybe we could use the distributive property and splitting numbers for numbers like 2.5. How would we do that, perhaps? We could do 2 times 3, a half times 3, add that answer to that answer, and you get your answer to 2.5 times 3. So you can see, here's another strategy for helping you do some mental multiplications. Split the numbers, calculate them separately, and then add the answers back together again. And that's completely allowed, and that's all to do with something called the distributive property of multiplication. Thanks for watching. Bye.